In the year 1666, in a small English garden in a Woolsthorpe, Lincolnshire, one man was sitting under a tree, doing nothing, as scientists often do. His name was Isaac Newton, and he was about to have the most famous fruit related incident in the history of human civilization.
Isaac, can you walk us through what happened that day?
Yes. So basically, I was sitting under a tree thinking about calculus. And I also invented calculus, by the way. And suddenly, an apple fell on my head. This is the apple.
And that's when you discovered gravity?
I didn't discover gravity. Gravity already exists. I just worked out on why it works.
Right, right. But the apple is what triggered it?
The apple is a fruit. All the apple triggered a headache. Ouch. Maths came later.
People think Newton just got hit by an apple and suddenly shouted gravity. But what actually happened is he spent 20 years in writing Principia Mathematica. It's a bit more complicated than just a fruit theory.
Let me explain what happened on that day. Basically, every object in the universe that has mass will attract other objects that also has mass. Let me give an example. I'm taking this apple. I'm going to drop it. Sorry, I'm going to move my hand. What do you think is going to happen? Is it going to float? Or is it going to drop down? Let's see. 3, 2, 1. It dropped down. And you know why it drops down? It's due to Earth's gravitational force. Because Earth's gravitational force constantly keeps going down. So even if you try to jump, you always come down. You won't stay or go higher. You come down. That's one thing. Second is you can actually break that law, a law of gravitation in Earth, by just throwing the apple up or by jumping, which I just showed earlier. That's two things. And also, I've been working on one formula for a long time now. Let me show you one. F equals G m1 times m2 divided by r squared. Here, F is gravitational force. G is gravitational constant. This also has a value which is 6.68 times 10 to the power negative 11. M1, M2 is just two masses. And lastly, R, which is the distance between two objects. So basically the force is proportional to the product of the two masses and inversely proportional to the square of the distance between them.
So it's like the bigger you are, the more you pull things.
Yes, essentially.
This is why the earth pulls you towards it. Earth is massive. It is about 6 times 10 to the power 24 kilograms. And you standing on the earth, you also pull earth towards you. But you are lesser. You are lesser in weight. This, shall we say, negligible?
In the interest of journalistic fairness, we also interviewed the apple.
Nobody ever asked about my side. I fell. I was just falling, doing what apples do. I asked to be part of a physics revolution.
How did it feel? Hitting Newton on the head.
Honestly, anticlimactic. He didn't even eat me. He just sat there for 3 hours with this look on his face. Very unsettling.
The apples being overdramatic.
Historically, we are not even sure that the apple actually hit him. His friend William Stukely, he has wrote that Newton saw an apple and hit him. The hit on the head version is possibly embellished.
Okay, let's be clear of how the apple demonstrated. 1. Objects fall down due to Earth's gravitational pull. 2. The acceleration due to gravity near the Earth's surface is approximately about 9.8 meters per second square. Gravity isn't a preference. It's a universal, non-negotiable rule.
Wait, so every time I drop something, it's Newton's second law.
Every single time.
So I have been doing physics this whole time?
So to summarize, gravity is a fundamental force between two objects of mass. The more massive, the stronger the pull. The farther apart, the weaker the pull. So Newton's universal law of gravitation says that F equals G m1 m2 over r squared.
You're welcome.
An apple.
I've never received any royalties.